Hello guys, good day and you are welcome back to this question. In this question now, we're asked, we're going to be tackling this particular one, all right? So we're asked here, what is the implication of each of the following statements? All right? So the following statements are what and what? This statement, and this statement. So we are asked what does they mean? What are the implications? Now let us read the first one aloud, even though it is written in set language, all right? So this one is read this way: if X is an element of A and then S is an element of C, implies what? All right. So what it implies is that set A is equal to set C, meaning that if this set A now has element which is X, and this set C also has element which is also S. So what it means is that this set A has the same element with this set C. And of course, whenever two sets have the same element, it means that those two sets are said to be equal. So the implication for this particular one would be that A is equal to C. Simple. Now, what about the second one? In the second case, in the second case now, it says if S is an element of D, then S is not an element of A. All right. So this thing you see here means not an element. Of course, this one means is an element. So this one means not an element. Okay, let me do it again. It says if X is an element of D and then S is not an element of A, implies what? So this particular one now simply means that A is not equal to D, or D is not equal to A, because it means that this set D has element which is X, and this set A does not have S as its element. So it means that this set D, all right, it means that this set D and this set A, they are not equal. So hence A is not equal to D, or D is not equal to A. Now, what about the last one? This particular one, it says if X is an element of C and then either X is an element of A or X is an element of B, implies what? It implies that set A is equal to set B, which is equal to set C. So what it means in a broader sense is that X, which is the element or the members in this case, is present in C, and the same S is also present in set A, and the same S is also present in set B. So if that is true, it therefore means that set A is equal to set B, which is equal to set C. All right, so that is it for this particular question. Now let us look at the next question here. All right, the next question is this particular one. Now let's read it. The next question says, write the following statements in words and state whether they are true or false. Now, of course, these statements you see here, they are all written in sets. All right. So these statements, one, two, three, four, all these four statements, they are all written in set language. This is actually C. Okay, so all these statements you see, one, two, three, four, they are all written in set language, and we are now asked two things. Number one, write them in words, and then state whether it is true or false based on our knowledge in sets. Okay, so let us start with the very first one. The first one now says, if S is equal to A, and A is a subset. That is what this thing means, all right? It looks like C, but it is a C. I mean, it is a long C. So whenever you see something like this means subset, all right? This is equal to subset, all right? So if S is equal to A and A is a subset of B, all right, and A is a subset of B, then S is equal to B. So we're going to write it in words now. Then we're going to state whether it is true or false. Okay, so let's write it in word. Okay, so this is the answer in words. If S is equal to A and A is a subset of B, then S is equal to B. Now, is it true or false? Okay, so this is the statement in words. So the answer to this one is false. All right, because if you try to reason this information, it's just trying to tell you that x is equal to a, and a is a subset of b, and s is equal to b. It is wrong because you can't tell me that x is equal to a and a is now a subset of b, and you're now saying that s is also equal to b. No, the statement is false. All right. Okay, the next one says if x is not an element of a and b is equal to a, then x is an element of b. So let's write it in words. Okay, so this is the answer in words. It says if x is not an element of a and b is equal to a, then x is an element of b. And this statement is not correct, hence it is false. All right, so this is the answer in words, and this is the answer. We are stating whether it is true or false. So this one now is true, just like, this one now is false, just like the first one is also false. All right, okay, so let's get into the third one. The third one says if A is a subset of B and B is a subset of C, then C is a subset of A. Okay, so let's just write it in words very quickly. All right. Okay, so this is the answer in words. All right. So if A is a subset of B and B is a subset of C, then C is a subset of A. Is it true or false? It is also false. Very, very important we understand that. All right. So the statement is not correct according to the language of set. All right. So it is also a false statement. Now, what about the last one, the fourth? The last one says if empty set. Okay, so for the final and last one, it says if the complement of empty set or null set is a subset of A and C is equal to universal set, then C is a subset of A. Okay, let us quickly put it in words. Okay, so this is it. It says if complement of an empty set is a subset of A and C is equal to universal set, then C is a subset of A. All right, so this statement now is actually true. Okay, so for this, so this is the question again. So I part of this question is false. I part of it is also false. I part of it is false, and the IV part of the question is true. All right, so that is it for this particular question. Now, see you in the next video. Thank you.